Okay, I'm going to work on this example a little bit. You can see in front of me I've already got the queued message handler example from National Instruments. Actually, this is in the project manager, so I created a project and pulled out their queued message handler. I noticed when I went online and looked at videos about queued state machine type designs that not a single person that I saw, and I looked through the first 10 or 20 of them, not a single person had used this. Everybody had their own version. And I guess I was that way for many years, but today I'm going to be different. Today I'm using National Instruments queued message handler. Now the way that this thing operates is, for anybody who's worked with computers a whole lot, I worked as a simulation engineer for a long time, so I spent a lot of time pressing buttons on user interfaces while the back end of the program was busy executing the 40 million simulations I had already told it to. So what happens is this explains why that works that way. If you read in the documentation here, it talks about queuing commands from the user interface, and then the message handler is actually executing things. You can sit up here and keep queuing all day long. It'll just keep adding to the queue, but until it finishes whatever task it's still grinding on, it's not moving on to the next step. That's how an interface like this works. But we're used to that, and we're used to seeing that, and we expect that as people who use computers. So it's a good paradigm. So without any further ado, let me pull up my list of things that I need to do here, and let's go ahead and knock these out. Okay, so number one, create an application that requires a user to log in before it is activated. I've sent an email asking some questions. There's a lot of different ways to do that, but let's see. The next thing, once activated and the run test button is pressed. So I'm going to go ahead and start there. We're going to start with run test, acquire 80 voltages. 80 voltages on a range from 0 to 8. So I'm going to make the next step. It's going to be press run. Is that right? Did I say that right? Run test. Run test. Okay, so we'll change the name of this do something replace me to run test. Now let's go over here on the front panel. Press to run. Alright, I like it. Here we go. And then what's going to happen here is we're going to wait until somebody presses that, and it's already configured to do this. And then we're going to do the something case, except there's not going to be a something case. There's going to be a press to run case. I'm sorry. No, it's already going to wait for press to run. Let's go on to this one would be, this is going to be acquire 80 voltages. Okay, let's kill that and queue it on the back end. Do something. Update display. It's going to enqueue that on the back end. So I guess we got to update the display. What's happening in the update display thing? display. Replace me. Where is this display? Oh, okay. Okay. Well, I don't know I necessarily want to enqueue this state, update the display, unless I put a message in there that said 80 voltages created. I don't know. Let's think about that for a minute. Let's go back to the state we were on and go ahead and have it acquire 80 voltages. Okay, so we'll move this over to the side a bit. Before we enqueue this state on the back end of the queue, which I really kind of like the fact that they've already done all this work. If you can just use this, you don't have to do all this thinking to try to set this up. And I'm just like everybody else. I've set it up every single time I've done it. But today I'm being different. And today I'm finding out that this saves a lot of time, which is nice. Okay. All right, let's go with, let's get the old random number generator. This one, as I recall, okay, it's going to be under numeric. It generates from 0 to 1. We're going to multiply by 80. It would do it like that. All right. We're going to do this 80 times. We're going to multiply by 8. And we're going to do this 80 times. All right, we're going to take these numbers out into an array. Love LabVIEW. They just made things easy. Good going, National Instruments guys. All right. So here's my little loop that's going to create the 80 different voltages. It says acquire 80 voltages on a range from 0 to 8 volts. Done that. Process the voltages, binning them in increments of 1 volt. That's going to be round to nearest. When we want to round up, round down, or round to the middle. How about just round to nearest? You could argue about which one is correct. You know, does this ever have the possibility of putting out a 0? Let's just go ahead and read about that real quick so we know we're doing it right. Let's read about this random number generator by going to help. That's not one I wanted to look. Okay, here it is. Floating point number between 1 and 0 is greater than or equal to 0 but less than 1. So it's round down. The distribution is uniform. Okay, so then it's round to nearest going down. So thank you for making it easy to find that answer, Nat. Good going, guys at National Instruments. So we're going to go round to nearest down. We just rounded by binning. Let me read the way he wrote this. Using a queued state machine, perform the following. Then graph them on a bar graph. So we'll go ahead and we'll say that's enough for this state. Let's add in our variables here an array of, oh boy, coming out of this, we can convert to an to a U8 or an I8. It's not going to matter. We'll just go ahead and go with I32. I changed my mind, I don't know why. Where's my I64? It's a 64-bit computer. Alright, so now I'm going to go ahead and put these out to a graph. Let's go to Update Display. What is that thing? Variant, converting the variant to data. Where is this variant coming from? What in the heck? It's coming out of the messages. It is enqueued. The data is being enqueued with the instructions. That's very interesting. Okay, alright, so they're enqueuing it up here. I'm glad I look at NI's examples because a lot of questions get answered. It's the questions I had at other times using this thing, like, hey, how is this supposed to work again? Alright, there's message data. So I guess you can enqueue things from the front panel in as data. Then you don't have to manage it, and they're putting it in as a variant data type. Okay, well, I'll tell you what I'm going to do, because I don't feel like figuring that out right at this moment. I need to sleep on that one and think about that variant thing a little bit. What I'm going to do is I'm going to put an array in this, and that's going to be where I keep the data, and I will make a graph on the front panel and just plop the data in that, because what I'm being asked to do here is very simple and I don't want to waste a lot of time. So, graph the bin voltages on a bar graph. Okay, so let's insert in here an array. Get in there. Oh, he's typed F to that. Find auto update from top definition. Open top definition. String replace me is here. So it's taking, now hold on just a second, I need to make sure I do this properly, because UI data here it is. Where's my control? I just opened the data control. Here it is. Okay. Message cluster. What is the difference between a message cluster Okay, so evidently they're passing that as a, they're passing the message cluster, they're passing messages. Oh, okay, well that's why it's called a message handler. That makes sense. Okay, let's just do it the way that I'm thinking. Let me try this. We might run into some problems here, but let me try it the way that I think. Alright, so now I'm going to put my array in here. Get in there, array, and it did. And now I'm going to put I32s. I'm going to make it an array of I32s. Okay. Save. Apply changes. Save again. Save early, save often. Oh, we're not calling it an array. Voltages. Acquired voltages. Well, that worked out real good, didn't it? There we go, like that. Save, apply, save. Okay. We're going to drop those. We're going to do a bundle by name. We are. Okay, so now we've got our acquired voltages. And he wants me to graph them. So what we're going to do, instead of in queuing this, do something, update the message. I'm going to enqueue a state called bar graph. No, I'm not. Determine pass fail. Determine pass fail. array constant, constant as undefined type. Now I'm going to go ahead and put a bar graph on here. Where's bar graph? I think that's waveform chart for some reason. I don't know anymore. Well, where did we go? There we are. Let's read it. Graph the bend ones on the chart. Determine pass fail. All right, let's go ahead and run what we got. Something was received in the message handling loop. I think we'll change that to acquire 80 voltages. That's not a bar graph, but That sure is. No, my rounding algorithm isn't right because I'm rounding down to set it can only be it needs to be rounded nearest. Okay, let's think about the math on that. I'm rounding down, so I'm getting 0 through 7.